Welcome to the Thoughtful Software Podcast with your hosts, Andrew Wolf and Fahad Shokat. Thoughtful software is a set of values, principles, and techniques to fuel digital innovation. We want to help usher in a new approach to the way software is imagined, designed, and built. In this episode, we are jumping into the cloud, specifically discussing how businesses can deploy a multi-cloud strategy to diversify services, mitigate risk, and enable innovation. Andrew and Fahad discuss the ins and outs of a multi-cloud distributed architecture and why it's essential for every technology business. Here's Andrew and Fahad.
So almost every company now has to be on the cloud to stay competitive. But as we expand more services to the cloud, that doesn't mean you should only use one cloud provider. Services within these cloud providers are often done differently and better depending on what you need to do. And companies like Zoom, for example, are not just using AWS, but Oracle. It's an interesting discussion around how companies can deploy a multi-cloud strategy. So this is going to be the focus of our conversation today. Andrew, maybe kick it off and help us understand what is a multi-cloud and why is it so beneficial?
Yeah, a multi-cloud architecture is where you deploy your solution to multiple cloud providers. And that, there are four prominent ones, five if you're counting Oracle, which actually should become a very competitive player here pretty soon. And that's going to be IBM, that's going to be Azure, that's going to be Google Cloud Platform, aka GCP, and Amazon Web Services, aka AWS. And so multi-cloud is the practice of creating multiple environments in one or more or two or more cloud providers, and then leveraging the unique capabilities of each of them.
What are some good examples? I mentioned Zoom. So what other examples of companies have you seen deploy a very effective multi-cloud strategy? And, what were some of their reasonings behind taking that approach?
So one of the most prominent companies on the planet, Apple, used Azure for a long time. That was their sole cloud provider. They've recently adopted AWS as a secondary cloud provider. And that's because, one, Azure doesn't meet all the complicated needs of Apple. And the second is, Apple is the same size as Amazon and the same size as Microsoft. And so when you look at it, they want to be able to not have that as a negotiating chip. Because imagine going to the table with Microsoft and say, hey, I want to partner with you on this, or I want you to stop doing this. And they say, well, I'll just shut your services down because I know if I do that, you can't compete and you can't, iCloud goes down. And so Apple's one of them. Dropbox is another one. They use GCP and AWS for different reasons. That's because storage. I mean, Dropbox has tons of storage, and they need to leverage a lot of different cloud providers to get the best storage costs to be able to provide a competitive pricing. Netflix was predominantly all on AWS for a long time, and they started to use GCP recently in Azure as well, because they didn't want to that be a competitive. They didn't want to go to the table and negotiate solely with Amazon. They want to have other options as well. And I think as you see, as the companies and the cloud providers start to differentiate from each other, I think you're going to see it more and more to gain a competitive advantage of that cloud without absorbing the downside of being locked into one vendor.
So let's make a distinction here. Like your mitigating risk is one part of it, where you don't want to have lock-in. I remember there's a story several years ago where Netflix went down and they blamed Amazon because they have also Amazon Prime, right? There's some competitive advantage. So I get that part, but there's also treating these different cloud providers as like backups to one another. But what about deploying like different services on different cloud providers because one is better at than the other?
Absolutely. For example, up till about a year ago, Google had such a competitive advantage with Kubernetes that the other services kind of looked really terrible. Now, Azure's made some really amazing hires, and their service is very competitive with Google's now. In fact, it might even be better. AWS is still lagging behind. But Amazon was the first company, and by a long shot, by 3 or 4 years, to have a MySQL and Postgres open source database that you could deploy that was managed. It wasn't until 2017, I think, that Google got one, and it wasn't until 2018, 2019 that Azure had managed Postgres and MySQL. That's a massive advantage if you're going to run a relational database on top of a cloud provider. And it's stuff like that. I think, yeah, until 2019, Microsoft Azure didn't have Redis, which is a very popular caching solution, but Amazon did. Google still doesn't have a search service on theirs, like Elasticsearch. Both Microsoft has their Azure Search, which is a worse version of Elasticsearch, and Amazon's the only one with managed Elasticsearch on there. So there's some real competitive differentiators, even at the lowest level, using some open source technologies that makes it where you want to adopt a cloud provider. But there are, if you can't just go with Amazon, you have a worse Kubernetes experience, and you're trading that for being able to provide a search capability and caching in your application. So you really have to think about which services you want to consume and how you want to consume them, and what's going to be the best way and the most cost effective way for your organization to adopt them based on the cloud provider.
Well, so this is really interesting. So then, kind of what you're touching on is multi-cloud support, and it seems like if you're a big company, you could just throw people at this problem and be able to support any type of number of services that are out there, and have the architects or the brain power to see, like, Amazon might be good here. What if you're maybe like a mid-sized company, or maybe you can describe, like, how do you actually support multi-cloud without having the resources to be an expert at each service provider?
So there are really amazing tools out there like Terraform and Puppet and other automation software that abstract a lot of this away from developers. For example, if you use the Docker standard, it's supported by all three major clouds in both container storage as long as container deployment in an automated way. And so when you have that, you're able to quickly move to cloud with using the same standard Docker build that you would on any other cloud. And so if you use the right protocols and the right open source standards and the right technologies, it actually isn't that you don't have to know how the cloud works, because there's already abstractions, there's already tools there ready for you to use. Now you're focused on learning a tool. So maybe you have to learn Terraform and Docker, but now you're able to use whatever cloud you want. And that's one of the advantages of using open source, and open source being so supported at these cloud providers.
Let's break that down depending on your company size. So let's say you're a large Fortune 500 and you have some on-prem service. You have your own system, and now you also have Azure or GCP. Like, how would you approach a multi-cloud strategy from a big, large enterprise?
So Azure is unique, and I think AWS offers it now too. Maybe I'm not sure. Where they offer what's called hybrid cloud, and so they allow you to deploy Azure and then use both on-prem resources and cloud resources if they were the same type of resources, which is a massive competitive advantage for Azure. And Azure's always had better enterprise support than the other cloud providers. It's because it's in Microsoft's DNA. Certainly not in Google's, and Amazon's catching up there, but it's hard, when Microsoft's been an enterprise company for as long as they've been in existence. And so there are solutions to support that kind of hybrid cloud in a uniform way. But if you're not, what I find is if you need an elastic workload, aka, can scale up and down, the cloud's perfect for that. And there's a lot of services that support that in the cloud. If it's a pretty static workload, run it in your in-premise and do it there. However, I still fully think you have to support an automated DevOps type situation where you're using a technology like Terraform or Puppet to manage your environments either way, even whether it's in the cloud or it's on premise, so that you're not worried about deployment and you're not worried about any of that kind of stuff. Because at the end of the day, all of it's the same. It's all compute resources, and they should be managed in a uniform, repeatable way.
That's interesting. So then let's talk about a mid-sized company. Now, how would you approach that? I mean, if you knowing that you don't have all the resources as a big enterprise, but you know that this is something that could be a potential risk if you don't adopt a multi-cloud strategy.
Again, I would start with an automation first type mindset, which is, don't spin up servers via UI, spin them up via Terraform or whatever. And I would automate. And when it's there, then you've capped your downside because you can always spin up your environment in another cloud, even if you're not thinking that way, right? It's a lower lift to do it. And so again, using DevOps best practices, making sure your environments are repeatable and all of that, and Midsize is very, very attainable. And you'd want it anyways. On automating deployments, you don't want your people going in there and deploying by hand. That people make mistakes and that causes downtime that costs you money, especially if have SLAs with your customers.
Okay. And then if you were a startup, would you even consider multi-cloud or just kind of just start building on the best service provider that you know in the beginning?
I would probably just use Heroku and Netlify, and I would go to town. I mean, you don't, at that point, you don't need to be worried about, oh no, it cost me $20 a month to get to 1,000 users and I could have spent 10. Spend your $20, dude. You're managing infrastructure when you need to be building product. And so I would even go simplified. Don't even go with a cloud provider in the beginning. Use a Heroku, use a PaaS, platform as a service, abstract as much of the management away as possible and just focus on building a product and building a team and building a company, because those are much harder than figuring out later that you have to figure out how to deploy things. I mean, if you get 1,000 users, you can raise money and pay someone to figure out how to get onto AWS, but worry about your problems as they come and earn your complexity. And certainly earning your complexity means, don't even worry about cloud providers. If you're worrying about that, you're worried about the wrong thing. If you're a startup, then just straight up.
Yeah, okay, that's good advice. So, keep an eye out for that. So there's one interesting thing. There's a huge demand for distributed architecture, like data meshes and data lakes. So how do you incorporate that into this multi-cloud strategy and start like architecting a more streamlined, platform?
So distributed architectures, those are very common in high scale services like Netflix and Dropbox and Box. They naturally lend themselves to a multi-cloud setup. And what that means is, if you set up distribution right, we're going to go real technical here. There's something called the CAP theorem. Okay. The CAP theorem, when you have more than two things trying to do the same task, you have what's called a distributed system, and it falls under the CAP theorem. And what the CAP theorem is there's three things you can have in a distributed system: consistency, which means that at any given time, the system is consistent with itself, has the same state, meaning has the same data within it, and that if I ask for A, I get A. In a non-consistent system, if I ask for A, I can sometimes get B, right? But in a consistent system, I always get A if I ask for A. The second is A, which is availability, meaning the system is always up and available. And the last one is P, which is partitioning, which means the work is perfectly partitioned across all the members in a distributed system. All right. And the CAP theorem is you can only have two of those, right? You can be CP system, which is consistent and partitioned, but not available. You can be AP, which a lot of systems are available and partitioned. And those are really the only other two things. You wouldn't mix CA, which is consistency and availability, because then the work isn't partitioned. And in a distributed system, that means that nodes can go down and bring your entire system down. So you don't really see any CA systems in modern computing. But in a distributed system, because the work is usually partitioned, that means you can put as many nodes in the distributed system as you want, and the work is divided. Now that's a cool property, because that means that no matter where that system is, whether it's in AWS or Azure or GCP, you can add nodes from anywhere. And so you can, in theory, have a distributed system running across 4 different cloud providers, handling work partitioned across them all. And as long as you get the work routing down right, you're going to have additional network latency as it leaves a data center and go to another one. But that's going to be minimum if that's what you're worried about in the multi-cloud. So a lot of distributed systems, a data mesh is a distributed system. The other ones you talked about, distributed systems, you can actually run them multi-cloud without too much of a issue, right? So one of your nodes in data mesh could be deployed to GCP and another one could be deployed to AWS, and it doesn't matter to the end users. Now, granted, partitioning work across multiple networks and stuff like that is difficult. But if you get the right front end to the system, or you use a CDN, a content delivery network type approach, which I can talk about a little more if you want me to. That's very technical. You can really easily handle it.
Yeah, I think that's actually an interesting point to touch on is like, I mean, if you have all these different services, what is that layer that can kind of abstract the details? And, how do you actually start managing maybe more automated services? Because you brought up automation. And how do you start streamlining some of this work? And what are the promises there? Is there any merit behind it? Is that a interesting like a is that an interesting thing to look at in maybe trying to abstract some of these complexities out?
Yeah, one of the popular types of architectures that exist today are microservices. And to make microservices work, because they can be deployed and they're elastic, meaning they can spin up and down, you have to do two different concepts to make this work. The first is something called service discovery. And what service discovery is a piece of software that sits, and it's a distributed piece of software. So get that, it's distributed software inside of distributed software. So you know it's going to work really well. And so you have the nodes check in with the service discovery, telling it where it's at. And then whenever something needs to know where to find a particular service, it can ask the service discovery platform, something like console is the name of one of them, to know where that's at to get to access to it. And that's one way of having the service discovery and to know where things are at. The other concept was called an application gateway. And what that does, it sits in front of your entire application and it uses service discovery and it uses other concepts to know where to route traffic to based on different paradigms. And maybe it's a round robin, meaning it's going to hit each service once and going back around. Maybe it's least frequently used, meaning I'm going to hit one up to a certain threshold and then I'm going to hit the other ones. There's a lot of routing protocols and algorithms out there that you have to look at your workload and how traffic's coming in to be able to really know which one to use. But between those two things, you're able to route the traffic to the right thing, and then you create kind of like a shared network inside of it by being able to use service discovery and application gateways. It also allows you to expose services under a different name and use naming protocols and stuff to really understand how and where the traffic should go. And there's cool properties here. And obviously, if we do a microservices episode, I'd love to talk more about the different parts of microservices and distributed architectures that make these kind of things possible and why they're needed.
Do you see this as like a threat to AWS or Azure in terms of like if they all can do Elasticsearch or Redis and microservices, and you have now these another layer that can just pick the best routing and pick the best services for you, then how do you actually really differentiate yourself? Like what is it that they could provide more services to enterprises?
So it depends on what you're trying to differentiate yourself with. Azure differentiates themselves with their enterprise support, and they're going more towards intelligent systems. Um, Google is trying to differentiate themselves with developer friendliness. Unfortunately, developers don't make buying decisions, so good luck. And then AWS is just trying to go wholesale, and we have everything no matter what. We have the most services. Azure has 87, we have 287, and why would you go with someone that had less things than us? And they're all trying to find their key way of differentiating in what they offer. However, I think in the race to differentiate, what's going to happen is most of these services are going to create a non they're going to create non-competitive solutions. So I mean, are generalized solutions that kind of work. Like I have Elasticsearch, but it's not as good as say hosted Elasticsearch, or I have Mongo, but it's not as good as Mongo hosted by Mongo. And that's where you're going to see solutions like Snowflake come in, where people find a hyper specialized solution and adopt that rather than use these cloud solutions that are they're available and they have some of the features but not all of them, because AWS can never specialize in one service because then the other 286 or whatever they have suffer because of that, but Snowflake can. And I think you've seen this with the unpacking of enterprise software. Back in the early 2000s and 2010s, people adopted this platform approach where it was like all in one, IBM, SAP, but now people are breaking that apart and they're adopting Box for file storage and Slack for chat and Zoom for video. And they're going into the situation essentially picking best of breed. And I think the same thing's going to happen to cloud services, where people pick the best solution and put that in their architecture and allow them to differentiate that way. And then they'll use the cloud for generalized things and other parts that they don't necessarily need the best of breed for.
So it's interesting you brought up Snowflake because we actually did an episode on data mesh architecture, which is kind of the next evolution. I'm just curious on your thoughts on data lakes and Snowflake. They recently just went IPO and they seem to be doing really well, but I'm just curious on what do you see in the future for them?
I think data lakes naturally will run just like any monolithic architecture. As you put more things in the monolith, it becomes less meaningful. The abstractions become less relevant, and they need to be abstracted further. The abstractions lose meaning because they're too general, and you start getting spaghettiification of the code. And what happens is the data lakes inevitably absorb complexities from the organization. Like, let's say I had marketing data into my data lake. Well, now I have to understand marketing a little bit. I had sales. Now my system has to understand sales and marketing. Now I had finance. I have to understand finance. Oh no, now I added operations. Now I have to understand operations data. Now I've added engineering. Now I have to understand engineering data. And you see how this complexity all comes in together, and this data is all living together. And so the schema gets more complicated. The code gets more complicated. Things start stepping each other. And just like any monolith, unless it's well kept, you're going to end up with an issue. And so I think you're going to see is, like I said it before on the data mesh episode, you're going to see it broken apart. Now, Snowflake's a great example of a best of breed service that could adapt with you, right? Azure isn't going to take their data lake and break it apart and make a data mesh service. No, but Snowflake potentially could. They could get in there and help you evolve because they're a self-contained ecosystem. They're doing one thing, which is data storage and management, and they're trying to do it really well, and that gives them the ability to outcompete Azure, AWS, GCP, or any of the cloud providers. And the same thing like Twilio. Last week, Azure launched their communication services. And I think that it's not really a competitor to Twilio because Twilio does one thing. The market's going to force them to innovate or they're going to go out of business. And so they're going to be moving quicker, they're going to move faster, they're going to be lean, and they're focused on one thing. So they'll be able to offer much better telecommunications, video platform, all of that better than Azure will be able to. But Azure systems will probably work for 90% of people who just want to send text messages or have calls in their app and don't need anything special or best of breed in their application.
That's fascinating. Yeah, I definitely would agree with you there. You obviously know more about it than I do, but I mean, you'll see some evolution. And so let's talk about that for a second. In the near maybe 6 months to 12 months, what do you see that's going to drastically change, or if anything? And maybe see what do you see beyond that that you find interesting in this space?
I think the next 6 to 12 months will be interesting. Like I said, I never thought Oracle would be a competitor in the cloud space. I honestly thought that they were going to lose big in a big way. But with this TikTok acquisition and partnership, and the fact that Zoom is using them and they're offering such great deals to people to start using them, they might be able to get back into the cloud space and be a legit contender. I mean, they're never going to be AWS or Azure, but maybe they could be a GCP or IBM, right? Can't ever rule them out. And so I think they can get in there and have a decent size market for what they do and win. And I wouldn't have said that 6 months ago. So I think in the next 6 to 12 months, look at Oracle as a legitimate competitor, not something, not number one. They're not a Super Bowl, but think of them as a playoff team. And I think as well, you're going to see a lot of differentiated cloud services coming out. I think you're going to see things. Snowflake just showed people that you can get 150x P&E multiple by coming out and having good metrics and being hyper specialized. I think that's going to be a game changer for people. And you're going to see a lot more of those, not just in the data space, but potentially other spaces as well. Search and other critical services needed for app architectures. I think you're going to see a lot more diversification too. I think a lot of people are going to start adapting the other clouds. And, we always talk about Google and whether or not they're going to be competitive to AWS and Azure, but maybe they don't have to. Maybe they don't have to be number one. Maybe they can be number three. But again, this is $100 billion space almost now. And so, you're talking about being number three in $100 billion space is $10 million, $20 billion, money sitting around. That's a huge line of business for anybody. and anyone should be proud of building it. And so, in that vein, I think you see GCP with a little bit of resurgence. But again, I think CIOs are always going to hesitate to adopt GCP because they like drop services like it's hot, and people are tired of it. I think the last trend you're going to see is the interest for companies to start potentially building more custom software. I think people are seeing that digital strategies built on these platforms and these non-specific applications that they're building don't really fit their needs exactly, and they cause the rollouts to fail, and they don't necessarily work the way they need to. I think people are going to start investing in custom software in a big way to hit their digital initiatives and their goals.
That seems like there's a lot going on. What would you recommend to developers as they navigate all these changes and these new services, multi-cloud? Like what would you recommend to your fellow developers?
I always tell my developers to learn the fundamentals. And in this case, the fundamentals of cloud development are open source protocols, learning Docker, learning Elasticsearch, learning Redis, and learning open source databases and how to leverage them cross cloud. And I tell them always learn the automation scripts, learn Terraform, learn Puppet, learn these techniques that help you spin up infrastructure without having to be expert on the APIs of these clouds, because a lot of these systems and a lot of these tools have abstractions in place for you. And so you don't have to learn the cloud, learn the tool that helps you deploy to the cloud. And that's much more valuable. And then once you know that, get familiar with the differing offerings people have and how they differentiate from each other. That's the biggest thing after that. Then you can make great decisions on where to deploy and how to deploy your system. And the third piece of advice is don't think about scale. Scale is easy, especially at business, because once you know how you're going to market, once you have sales, you have money, and money can buy yourself, you can just buy bigger servers. And it's a joke kind of, but it's not, it's the reality of don't put your cart in front of your horse. Worry more about your application architecture, more about how you're writing your algorithms inside your code, because then you don't have to worry about scalability. The code will scale itself. Most modern solutions, they're out there, they can solve your problem, but only if you write good code, maintainable architectures, use best practices with tests and everything like that. I'd focus more on that than I would the cloud or anything like that.
Yeah, I find it hilarious when people ask you, like, how are you going to scale? And I'm like, well, I'll let you know when I get to my first customer, then 10, then 100, then 1,000, and I'll figure it out as I go along.
I swear to God, I've never met a business owner that's asked another business owner, how are you going to scale? Because they look you in the eyes and they already know that the only way you're going to scale is not sleeping at night, blood, sweat, and tears. That's the only way you scale. And it is what it is.
Yeah, there's no right answer there. So as a final thought, this is really interesting, strategy that companies could take, to help mitigate risk, cap downside, diversify their services. What does this all mean for the end user, like you and I, watching Netflix, or how we're consuming these services? Like at the end of the day, how does it benefit us?
I think it benefits us because there's the additional competition always brings out innovation, right? Where people do cool things, it drives down cost and it makes things more affordable. One of the reasons Uber is so affordable isn't just because they're losing money, but it's because cloud infrastructure is so cheap that they're able to scale their service with very little to no cost to them. And this competition causes these things to, realistically, cloud computing is almost free. Google gives away what, like $1 million in credits if you sign with them. That makes startups be able to scale much cheaper, much easier, and that brings innovation to the crowd. And so, as long as there's competition, I think you're going to see a lot of innovation get to the end user and get to people, which is cool. That's really amazing when you think about how the competitiveness can drive down cost to allow innovation to happen. When you were first building a startup 30 years ago, you had to buy a server and put it in your basement, right? Hook it up to the internet, right? There was no cloud. There's no, where do I put this thing? You had to go put the server in your basement, write the code, move it to a data center, and hopefully you knew how SSH worked. And then from there, you could potentially put it into, put your code and deploy it remotely. But even then, that was a time consuming thing. And it cost, $1,000 to put a server a month in a data center and get the rack space for it. I mean, that's expensive and it's hard. And a lot of people don't have that kind of capital, but now you can go download free servers from AWS or Google, which allows startups to happen. And without that, I think we take that for granted, that the infrastructure. I was telling a friend of mine that, you know, when you think about where we're at in the history of the internet, we've just got done building the railroads, Fahad. Like that's all we've done. We've built railroads, but now we're starting to build the things, like oil and things that go across the railroads and shipping things and steel. And now we're starting to build on top of the infrastructure that's been set out in front of us. And I think the cloud's just part of that infrastructure, those railroads, those bridges that we need to build. But now we're one connected coast to coast country, aka the internet. Now we're ready to really start building some cool stuff, some really amazing digital innovation.
Thanks for listening. You can always connect with us at skiplist.com.